So this is an example as well. So you've got the big C peak and the small a, and the software is picking it up as a C when it is clearly an M. So this is a problem. So possible causes of PA. First of all, could it be the primer design? This is not the case because my specificity was confirmed when I amplified the homozygotes. So the second possible cause could be primer binding efficiency. So I thought to decrease the stringency of the PCR with either of two ways, increasing your DMSO concentration or decreasing the annealing temperature. DMSO works in PCR by enhancing the specificity, by lowering the effective melting temperature of the primers. It reduces the complex secondary structures in the target DNA, although it can inhabit Taq polymerase, so it's a bit of a sort of a balancing act between these two, and it's normally used between 1 to 10%. So initially I was using the 1.5%, and then I tried at 2.5, 3, 3.75 and 5. As you can see with the 0301 that did not amplify at 1.5, you can see the product, a faint band and then a stronger band at 3%. So I sequenced everything except the 5%. And as you can see from the table, you can sort of see the second alleles coming through for these samples, but it wasn't until the 3% DMSO that you were getting both alleles for all those samples that had PA. So the sequence quality and allele identification was comparable at 3% and 3.75%. So 3% was chosen because, as it's known, that DMSO at high concentration can inhibit the PCR. So using 3% will allow for PCR variability. So then I re-amplified and sequenced the panel again. Unfortunately, I was now getting PA against my 05 and 06 in the presence of the 0201, the 0303 and 0304. So the next step was to decrease the stringency by changing the annealing temperature. So I did a gradient. So this is what it was at the beginning, at 62. And I've decreased down to 56. And I'm still having a problem with the 0201, 06, 02. I did want to make the note that at 57 and 56 degrees I could get 06, 02, but I had to do operator editing. And as I mentioned at the beginning, we don't want to have to do that. That's not part of our QC for our sequencing.
Jackie, is that with or without DMSO?
This is with the 3% DMSO. So I've started with 3% DMSO and then now I've just dropped the annealing temperature. So conclusions, primer specificity confirmed, are able to split the DQB1 0301 from the 0319, and amplification was achieved in the single tube. Future plans, I've got to continue resolving the PA issue, and then once that's resolved, optimise the single tube assay, and then implement in the routine diagnostic work. Thank you. Yes.
Thank you very much. So let's first have the students ask questions before Marcelo is asking questions, because I heard several of them are working high resolution sequencing, so they can give
some hints. Help me.
Yes.
Hi, thanks for your talk. Have you, before you moved to the single tube situation where you had 3 tube reactions, did you also see the preferential amplification?
With the 3 separate tubes?
On the exon 2
No.
reaction?
No. So that currently everything's fine. It's once we put it in the
okay.
single
And
tube.
did you move to different primers, or did you use the same primers for exon 2?
No, I moved them. If we just go back, because originally
you were too much in the exon.
yeah, so we sort of had them on the edge of the exon, like exon 2 and then exon 3. So what I wanted to do was put them in the introns. So I've moved So this is new, and this is the only primer that's the same as our current. So all these three primers, all the primers.
Okay, because we are also having a protocol for this company. But the intron position, intron 2, it's not too big. So have you tried to use a polymerase that is doing the long range? For instance, using exon 2 forward and the exon 3 reverse to make one amplicon?
We have tried that. We did use the long range and try to amplify, but it didn't amplify very well at all. So that's why we've gone.
And which polymerase?
I can't remember off the top of my head. Might be my.
Oh, we can talk about details later.
Yeah, might be my notes.
Okay.
Yeah,
Thanks.
later.
Any more suggestions? Yes? Sure. Mary.
I was just going to make a comment that one of the commercial Luminex kits seems to have the same problem in the last Asiata exchange. I don't know if you've seen the results, but
I haven't.
they seem to have the same dropout problems. But you designed your own primer in-house, it's not a published.
Yes, no, we designed our primers.
Yeah. So
I'm
you're
not
the
alone.
only one.
And Shannon, still valid?
Yes.
I come to you.
Yes, this is a very nice presentation, and actually, I think we saw that problem historically with the DQB exon 2 primers in workshops and so on, and lowering the annealing was the solution when we were doing SSO.